Hello and welcome to my video demonstration about the knowledge I learned from this class so far. For starters, as we developers, we need to know how each page on our website is rendered when we start our server or when users open a URL. So when a user through their browsers sends a request to access a particular URL, this request is redirected to the server where our Node.js application resides. Once Node and frameworks like Express receives this request, it identifies the route or endpoint being accessed. Routes in Node define how the application should respond to a client request to a particular endpoint. If the requested page requires, the Node server communicates with the database and make appropriate queries. The database processes the query, fetches the relevant data, and sends it back to the Node.js application. Upon receiving the response, the browser renders the initial HTML and executes the included JavaScript. This JavaScript is responsible for dynamically generating the page's content using the provided data. Once the page is generated, Node.js sends the HTML response back to the user's browsers. The user's browser receives the populated HTML and begins rendering the page. Any linked CSS and JavaScript is applied and executed. This JavaScript can further manipulate the DOM, potentially fetching additional data asynchronously if needed without a full page reload. When the page fully rendered, the user can now interact with it. Any further interactions that require new data would initiate a new cycle of communication between the front-end, back-end, and potentially the database. Just as our brain processes input, computes decisions, and then acts, a web application also has its sensory organs, its decision-making center, and its memory. The front end is like our sensory organs. It's what the users see, touch, and interact with. Everything from the buttons users click to the forms they fill out resides in the front end. Built primarily using technologies like HTML, CSS, and JavaScript, the front end captures user inputs, processes immediate interactions, and requests or displays data. It's our direct line of communication with the users. While we often marvel at the beautiful website designs or smooth animations, the real functionality of the front end is its ability to convey and gather information. When a user submits a form or clicks a button requesting data, the front end packages this information and sends it off to the backend, awaiting for a response. Once the front end sends its request, the backend or the brain of our operation gets to work. If the front end is about interaction, the backend is all about logic, processing, and decision-making. Built on server-side technologies like Node.js and Express, the backend handles complex operations, authentications, and data processing. Here's where our mental map gets fascinating. When a request reaches the backend, it may need to fetch or store data, but the backend doesn't hold this data. It must communicate with a database to retrieve or save information. After processing, the backend sends a response back to the front end, either the requested data, a confirmation of successful operation, or an error message. Now let's talk about the memory, the database. Just as our brain stores memories and information, databases retain data for web applications, whether it's user profiles, blog posts, or transaction histories. The database is structured memory unit. Databases like MongoDB serve this purpose. They await requests from the backend, fetch or store data as instructed, and then report back to the backend. You can think of the database as a library. When the backend or the librarian receives a request, it fetches a relevant book from the shelves. Once the data is retrieved or stored, The backend then processes it as necessary and sends the response back up the chain to the frontend. So as you can see, the flow of information is as a circuit. The user ignites this process by making a request or input on the front end. This request travels to the backend, which might then seek the database to fulfill the demand. Once processed, the response retraces this path, going back to the user. At each stage, specific operations and checks occur, ensuring data integrity, security, and efficiency. Now let's talk about the key concepts we've learned, including HTML, CSS, Bootstrap, JavaScript, Node.js, Express, MongoDB, and Forms. For starters, as a web development class, the very first thing we learn is to create static web pages, which mainly uses HTML and CSS. HTML is the functional blueprint of the web, serving as a structural skeleton. When you visit a website, everything you see, from headings and paragraphs to images or links, is defined using HTML tags. These tags provide a structured way to present content, enabling browsers to interpret and display it correctly. HTML is indispensable. Without it, the web would be lack form and meaning. After setting up the content with HTML, the next step is to use CSS to style and lay out the page. CSS is the aesthetic designer of the web, where HTML sets the structure, CSS determines the look. It's about colors, spacing, fonts, and layouts. With CSS, developers can transform a basic web page into a visually appealing experience, optimizing for different device sizes and screen sizes. It's the difference between a bare-bones structure and a vibrant, user-friendly interface. And during the process of designing and developing static pages, we've also learned to find and implement the most suitable templates on Bootstrap, which is the web's toolkit for quick and responsive designs. Bootstrap is a CSS framework that provides pre-designed components, ensuring consistency and saving time. From buttons to navigation bars, Bootstrap offers a bunch of elements that automatically adjust for all device sizes. It's like having pre-designed building blocks ready for assembly. After getting familiar with designing and developing static pages, the next thing we learn is to make our web page dynamic and responsive. It also allows dynamically change and re-render data on the web pages. All this requires the use of JavaScript. JavaScript is the dynamism of the web. While HTML and CSS provide structure and style, JavaScript introduces interactivity. It's what makes web pages react, evolve, and engage. Since JavaScript allows dynamic content changes without page reload, it helps achieve a wide range of dynamism from simple animations to complex single-page applications. From the front-end perspective, JavaScript drives the dynamic content that users expect in today's digital landscape. But what we've talked about are basically limited to the front end. And if we aim to develop a running website, we also need to consider the backend. Although historically JavaScript are mainly for the client side, its evolution didn't just stop at the browser's edge. Node.js expanded its horizons and brought its capabilities to the server side. Now, with the help of Node.js, not only can we create interactive front-end experiences, but we can also build entire server architectures in JavaScript. Node.js represents a paradigm shift, bridging the traditional divide between front-end and back-end development. However, setting up server-side logic can still be hard, and that's why we use Express, which is a minimalist framework that makes the process of setting up a server a lot easier. Express acts as the middleman between raw Node.js and the developer. It offers a simpler interface to set up the routes, middleware, and handle requests and responses. With Express, the creation of APIs, the management of cookies, and the setup of various HTTP methods become almost effortless. Now with both front and backend covered, we need to utilize database to store and show data in our pages. And we turn to MongoDB. Standing out in a crowd of relational databases, MongoDB is a non-SQL database, emphasizing flexibility and scalability. Instead of rigid tables and rows, MongoDB provides collections and JSON-like documents. This format not only aligns seamlessly with the JavaScript ecosystem, but also accommodates diverse data structures without rigid schemas, allowing developers to adapt as needs evolve. With everything that's covered so far, we could now build a functional and dynamic website. However, for lots of important functionalities, there's still one problem to be addressed. That is allowing users to input data and store them. Forms are the communication channel of the web. They help users talk to the web applications through registrations, feedback, or data entry. Forms capture, validate, and transmit this user data. With modern technologies, they've evolved beyond mere data collection, offering interactivity, real-time feedback, and enhanced user experience. Now we've talked about each channel separately. Let's see how these two work together in the web. For front-end, HTML provides the fundamental structure, ensuring content is semantically represented, laying the groundwork for all subsequent layers of design and interactivity. CSS introduced the visual layer, encapsulating the design philosophies and providing user-friendly and aesthetic interfaces, tailored for varying devices and resolutions. Bootstrap serves as an accelerant to this process, offering a cohesive set of design components optimized for responsiveness and user experience. JavaScript then is the catalyst for interactivity, enabling dynamic content manipulation, asynchronous operations, and real-time user engagement. As for backend, Node.js extends the JavaScript ecosystem into the server realm, leveraging its event-driven architecture to efficiently handle concurrent operations and makes everything accessible online. Express then acts as the backbone of many Node.js applications, providing a simplified yet powerful framework for routing, middleware integration, and server-side logic. And finally, for data management, MongoDB offers a contemporary approach to data storage. As a document-oriented database, it supports dynamic schemas, ensuring flexibility and integration with JavaScript-based backends. Forms, while often interfacing on the front end, play a very crucial role in data collection. Modern forms are equipped with real-time validation and feedback mechanisms, and they ensure data integrity and optimize user experience as data transitions from the client to the server. Now let's delve deep into Node.js and learn how to set up the server. JavaScript for many years was limited to the realm of browser-based actions that changed drastically with Node.js. It wasn't merely about running JavaScript on servers. It was about changing the narrative of server-side programming. Traditionally, server-side scripting was synchronous. Every request waited for its turn. Node.js brought the power of asynchronous input-output operations, thanks to the event-driven architecture it provided. Every function in Node.js is non-blocking. The event loop keeps the execution going, pulling for other events, ensuring operations don't keep other tasks waiting. This mechanism allows Node.js to handle thousands of concurrent requests efficiently, making it incredibly scalable. And Express encapsulates the raw feature of Node.js into a refined framework, making server-side development more intuitive. For routing, at its core, every web application is about directing incoming requests to appropriate handlers. Express makes this easy. For example, the first code piece would handle GET request to the user endpoint. Accessing this endpoint and add 123 after a slash would yield user ID 123. Handling query strings is also straightforward. As you see in this piece of code, it searches for Q in the URL, so simply include Q equals a string in the URL would pass the string to the function. As an example, accessing the search endpoint and include question mark Q equals express would display you search for express. And for middleware, think of it as a series of layers, each performing a specific task. When a request comes in, it traverses these layers sequentially. One middleware might parse incoming JSON data. The next would authenticate an user, and another could fetch data from the database. Middlewares can either conclude the request response cycle by sending a response or pass control to the next middleware. In this code example, the first middleware serves static file from a directory named static. So if there's a file named index.html inside the static directory, this page will be what the user see when they open your website. The second middleware parses incoming requests with JSON payloads. It's essential when you want to handle JSON data sent via POST or PUT requests from the client. The last middleware mounts the router object to the path API. Any request with a URL starting with API will be routed through this middleware. Express enriches the raw response object of Node.js. The raise object is your gateway to formulating the HTTP response. Here are different ways to send responses. There are text response with simple send, JSON response with res.json, HTML response that parses HTML as the parameter for send, or send files with res.sendFile. You can also set specific HTTP status code using Express with the status method waiting for matching status and the send method handling error messages. Additionally, Express also facilitates redirections with the redirect method. In essence, Express provides a comprehensive framework for defining routes, utilizing middleware and managing responses. So for NPM, any discussion about Node.js is incomplete without mentioning NPM. It's not just a package manager, but also a vast ecosystem. The big libraries available, ranging from utilities to full-fledged frameworks, have significantly reduced development time. Starting a project becomes standardized with NPM in it. The resulting package JSON file, as shown here, is more than a list of dependencies. It's a manifest that ensures consistency, reproducibility, and provides metadata about the application. Moreover, NPM install allows easy installation to your project. For instance, as we use Express and database like MongoDB, we can include them in our project with simple NPM install. As we've mentioned before, Node.js allows connecting to databases like MongoDB for CRUD functions, which are create, read, update, and delete. In this case, they each has a more specific meaning. Create means insert data into our collections. This is done by defining a post route to insert data into our database. And in this code, we use insert1 to add one record to our database. Read means fetch data based on queries, and is done by defining a get method, as shown here. Well, first pieces of code, like this one, we are fetching all records from our database using the find method and converting the result to an array containing all the data in the database. However, to fetch specific data based on criteria, we modify the above code and we retrieve records where the name field matches a certain value. Simply add names in parameter and use find method to query data and that has matching names. Update means modify existing data, and this function requires both a condition to match with and the changes to apply to. In the code here, we define a put route and uses the update one method to update one record in our database. And finally, the delete means remove data from the database. And it is done by defining a delete route, and we use delete one method to delete one record. When developing our application, the best practice is to separate our files into different modules. It is important to keep in mind because modularizing our code provides several advantages. First is maintainability. Since changes in one module don't affect others, it helps reduce the risk of bugs. Second is scalability. As our application grows, we can add more files and directories without restructuring everything. Third is collaboration. Multiple developers can work on different modules without messing up others' code. And finally, reusability. Modules can potentially be reused in other projects or shared with the community. With everything we've covered so far, let's now look at a real-life example. So since we want to start our server with Node, let's first use npm init to initialize Node in our project. And this is going to get us to create a package.json file, including all the dependencies needed to run our program. And since we're using MongoDB and Express, let's install them. After they are installed, you're going to see Express and MongoDB in your package.json dependencies. And let's now start our program. So the first thing we do is to import Express. So we can use Express in our program. And this middleware tells the backend that if it is using static files, you need to look in the public directory. So let's create one. And create an index page in this directory. And this middleware tells your program that it needs to parse the result that is in JSON file. So now if we want to start our program with npm start, we need to add a script. And since we're running with node.js, we need to include node in this line. And we want it to run with backend.js. And since we're using the import module here, we need to include app equals module in our package JSON. So after setting up the backend, let's now create a routes for our website. So as I've said before, the best practice is to modularize your code. So let's create a directory for routes. So in this file, the first thing we do is also import Express. Now we construct a router. So now we can start setting up our endpoints. Let's just throw in some random names to see if our API is working. Let's export our default router. And as we create this file, we need to link it in our backend.js. So we import. And add a middleware for our API. So now every URL that starts with API is going to try to find the endpoint in here. Let's call this names. Okay, so now in our HTML, let's put in something to see if our page is working. And let's create a JS directory inside the public directory to include all our front-end JS files. So let's create a file and call it frontend.js. And remember to link it in your HTML. Let's create a div as a container to hold everything we put in here. So let's give it an ID and call it person. So now for our front end, let's first construct an empty object. So we can just export this object after finishing up our front end. And let's create a render person method to render our data in here into our HTML page and give them a format. And this is for rendering individual person information. So let's have another method called render all. And we give this container the ID person. And let's return this main object. And finally, at the end, let's export. And now we need to include this results in our front-end JS. So let's define a method called reload person to fetch the information from the API.js. And since we have a wait in here, we need to make the function asynchronous. And when we export, we directly call the reload person function. So now we set up the data, the endpoint, and also we have all the linked files in correct places. So let's now try run our program. We can now see the heading we set up in our index.html, but we still don't see our data we just set. So we can see the console here for the errors. So this error message suggests that the server cannot find front.js in our linked address. So let's see if we can fix this. And try to run our program again. So now we can see all the names we put in our API, and they're shown here in the format we indicated in the frontend.js file. So the next thing we do is to import data from the database instead of using this directly. So in my MongoDB, I pre-set up an example database for this usage. And the database is called example, and I call the collection data. It has a name field and an age field for 4 different persons. So let's create a new directory called mydb and create a mydb page for loading data from our database. So the first thing we do is also import and define a function called mydb. So the URI is going to be used here, can be copied from here. And here's gonna contain our database information. So let's copy the name of our database and put it in here. We return these two variables from this method. For getting the information from specific collection we want, we need another method. Let's call it get person. For the collection name here, let's copy our collection name. We're going to use a try block for fetching the information from our database. And since for now we're trying to fetch all information from database, we're going to leave the find parameter blank so we can get all the information in our database. And finally, is going to be the default result. And let's return MyDB. And after setting up this file, we need to link our MyDB into our API. So instead of input this name manually, we're going to export them from our database. And our method is called getPerson. So now let's modify our frontend.js and include more information. So let's add another and let's try running our program. So now we can see each person's name and age. So this is how you set up a working server and connect it to the MongoDB database.